Agents are your colleagues and you do not want a forgetful agent. So in this video, I'm going to show you on how to build different memories for an agent. We are going to start with a basic no memory agent, which is a dumb agent, and then we are going to go into an in-context history memory type. So this is like an agent who remembers what you have told in a session but doesn't remember all the previous sessions. And then we are going to go in a summarization technique, which is a very efficient way in which you can have in-session memory. And then we are going to go into the file persistent memory type, where an agent can remember across the sessions. And then we are going to use also an advanced approach called a semantic vector store memory type, where an agent can remember across the sessions but in a very efficient way. So for this, I'm going to use various Python packages, and here I'm going to use large language models from Anthropic, which is Claude agent, and I'm also going to use OpenAI large language model. So for both of these, you will require some API keys. Let us start with the first, which is the dumb agent, which doesn't have a memory. So here you can send all the chats to a large language model, but it is going to forget everything. So for example, if you ask a questions such as, my name is Alex and I'm writing a paper on attention mechanisms, and then you ask another question, what is my name? The agent has already forgotten that your name is Alex. So you can see here that first is, it is going to say that yes, this is a great topic and the agent is ready to help. But then this dumb agent, if you ask a question, what is my name? It has forgotten everything. So the issue is that the agent doesn't have memories between turns, and let us see on how to fix this. So here you can create a memory which is by storing all the history of all the conversations. So what you do is basically whenever you are getting a reply from the agent, you are just appending into an object which is called as history, and then you are passing the complete history to the agent. So for example, you ask a question, my name is Alex, I'm a PhD student and I am writing a paper on attention mechanism. And then if you ask a second question in the next turn, that what is my name and what is the deadline, it is going to remember because you have passed the history to the agent. So here you can see the responses. So this is hello Alex, great to meet you, and then it is describing something on the attention mechanism. And then when you ask a second question, yes, it is remembering that your name is Alex and your deadline is 15th of July. Now if you also ask a question such as, suggest one related subtopic, even though this question doesn't know the main topic, it still remembers that your main topic is around attention mechanism, and it is going to suggest you a subtopic which is efficient attention mechanism. So this is a very nice approach in which you can build the memory of an agent using history, but there is an issue. The issue is that your context window is going to grow and grow with every conversation. So here already you have passed 6 messages and your context window is already 332 words. So the problem is that context windows are finite and every token in the history is going to cost you money, and this approach is eventually going to hit a limit. So Claude Haiku supports 200k tokens. It is big, but at one point of time, even your agentic history is going to grow above 200k tokens, and this is going to cost you a lot of money, lot of tokens, and this approach is not very practical. So let us now go to the third approach, which is compressed memory, in which you are creating a summary of the history. You are not storing the complete history, and this helps you manage the token cost and the context window. So the way in which you do it is basically you are asking the Claude to summarize the key facts from all the conversation. So your history is not the complete history, but it is summary of the previous conversations of the previous history. So for example, you can see here that we are going to ask various questions, and then at every point of time, the agent is building a summary. So for example, at the final question, it is storing a summary of the key facts. It is not the complete history, but it is just a summary of the key facts which is then used to answer the question. So this is a very efficient way to not only have the agent a memory, but also ensure that the context window is a summarized version. You are managing the context window in a very efficient way. But the problem still remains that the agent is not going to remember things between the conversation. So for example, if you start a completely new conversation, all the summarized history is lost and the agent is not going to remember anything. So the solution for this is the episodic memory, which is persisting the history in a persistent file. So for this, we are going to use two tools. One is to save the memory into a JSON file, and the second is recalling the memory from the JSON file. So how this works is, whenever you are creating the history, you are also storing it in a file, and your summary, in fact, is then created from this file. So you will need two tools. The first tool is saving all the important facts into a persistent memory. And when you save it, you are going to create an object. And this object has got a property, and there are two properties. First is the fact. So this is what are the important facts to remember. And then it will also have a category, which is the type of the memory. Like, is it personal, is it project, or is it preference? And when you are recalling it, you are basically recalling the object with all the properties. So let us see on how this works. So here you are passing this prompt that you are an helpful personal assistant, and you have to save everything into facts using this save memory. But whenever you are unsure, you should use this recall memory to read all the previous facts as well as properties. So how this works is basically you are going to ask various questions, and here I'm creating two sessions. Now these two sessions are completely independent of each other. In the first session, I'm writing a prompt like, I'm Alex, I'm PhD student in MIT, I'm working on a paper. And then a second session, which is a completely new session. Do you remember anything about me? So in the first session, it is going to save all the facts, and let us now see this JSON file which gets created. So this JSON file is basically an object where you have the different facts as well as the category of the fact. So for example, the fact is Alex is a PhD student, and the second fact is Alex advisor is Professor Chen. So now when it is retrieving in the second session, when it is retrieving the memories, because the agent is not sure on what is the answer, so it is going to call this recall memory, and this recall memory is going to read all the facts about the personal status of the student as well as what is the current project the student is working on. And then based on that, it is going to give you the answer which is very relevant, and it seems that the agent has completely remembered all your previous facts, and it is going to reconstruct your answer based on the memories which it has recalled. So this is also a very nice way, but there is still a problem that all the facts what you are going to load in the prompt can also become quite long. So if you are going to retrieve all the memories across all the different sessions, at one point of time, you are going to again hit the limit of the context window. So the solution is to use a semantic memory where you are going to vectorize all the memories, and you are going to store it in a vector store. And then when you are retrieving the memories which are only relevant memories. So for this, you will need an embedding model. So here I'm using an embedding model from OpenAI, which is this text embedding 3 small, and then you are going to retrieve all the similar memories using this cosine similarity function. So let us now see on how this works, and let us say you have already created a memory bank and you have already vectorized all the different memories of the conversation, and then you are asking all these different questions. So this is your memories which are stored in the vector store in embedded format. And let's say you ask a question, what is my paper deadline? In that case, it is not going to retrieve all the memories, but it is only going to retrieve only the relevant memory. So if the question is on the paper deadline, it is going to retrieve the memory that Alex paper deadline is 15th of July, this particular memory over here, as well as Alex is writing a paper on attention mechanism, which is this particular memory over here, because they are semantically similar to the question. And the answer is basically based on the memories what we have retrieved. So this is a very nice way, very efficient way to ensure that the agent remembers across the sessions, as well as it does it in a very efficient way. So all the different memory types have got different use cases, but the key takeaway is that in a production architecture, you are going to need to combine all these 4 different types. So now my question is, what are the different use cases what you have, and what are the different type of memories you think you should be using? Comment below and let me know your answer, and please like the video, please follow me, please subscribe to the channel. Keep learning and see you soon in the next video. Thank you. Bye.